Hey everyone, it's Chris Ward with the CBT Nuggets on designing and implementing your server infrastructure. Today's nugget is going to take a look at Dynamic Host Configuration Protocol and what considerations do we need to have when we design this into our infrastructure. When you're designing your Dynamic Host Configuration Protocol, or DHCP, there's a couple of things that we need to take a look at in this nugget. First off, designing where our DHCP servers are going to be in the infrastructure themselves. Now, one option, of course, is to think about it from a virtual world and put them in as VMs. That's really good because DHCP servers are actually very low overhead. So if you just spin up a server in a virtual machine and then slap on that DHCP role on it, hey, no problem. That also is good if you already have a virtual machine for a server. A DHCP role is not going to add a lot more overhead to that particular server. So that's one thing to think about, and we'll talk a little bit more about that. The other is DHCP failover. Nothing worse than having your end users go to you and say, hey, I'm not getting an IP address, or I'm not able to hit the internet. Well, of course, once you have them do a IP config on their computers and it gives them the 169.254 APIPA number, then you know, okay, DHCP is probably giving me some problems. Well, with DHCP failover, we can make sure that if one of those DHCP servers goes down, there's another one ready to pick up the slack. When you are designing your server infrastructure, because that's really where we're at, we need to know where are we going to be placing these DHCP servers. And otherwise, your network isn't going to function very correctly. You need to make sure you're deploying your DHCP servers where they need to be. Now, there's a couple of different ways that you can do this. You can do this in a distributed way. You can centralize it where you just have all the DHCP servers in one location. Or you can combine, which obviously is going to require a little bit more work. Now, if you do it distributed, this means that you're assuming perhaps maybe you don't have any DHCP or Bootstrap protocol, or what sometimes is known as BootP relay agents are in place. So that way, you must put a DHCP server for every single subnet. Now, obviously, if you have an organization that has thousands of users, that is not very practical. It's going to basically mean you're going to have a huge number of DHCP servers. You've got to manage all those DHCP servers, and that can, of course, cause problems. So what a lot of people think is, well, obviously, let's go ahead and put DHCP servers all in one central location. Maybe I would put all the DHCP servers here at my Phoenix location. So here I've got my Phoenix location. I've got all my DHCP servers here, and then of course I've got my Eugene location for Nugget Lab, and maybe I've got my Chicago location. And guess what? Users can still come up and get their IP addresses from the Phoenix location, but you need to make sure that you have DHCP BootP relay agents. Remember, this allows you to forward requests from remote subnets. Now, this might work much better in a single location, but if we are using a WAN link between these two, like Eugene and Phoenix and Chicago and Phoenix, well, what happens if you fail that WAN link? Uh-oh. That means we've got some problems. So what a lot of people do is they go with the combined infrastructure. So each WAN location would have maybe one or more of the DHCP, and then of course the larger location, if Phoenix has more people, you can add more. This gives you centralized management of the DHCP servers, but you don't have to worry about these WAN links going down. And of course, remember that any routers that are connecting must have DHCP BootP relay agents in place. The good news is most modern, up-to-date Cisco, Juniper, all those guys, they all have that in place. But of course, you also might need to talk to your network security people about whether they want that type of relay agent operating over the WAN link and how that all works. But again, that's beyond the scope of this particular Nugget series, but it is something to think about if you are going to be doing a combined environment and whether you're going to allow these DHCP to BootP relay agents to work. Another thing to think about when you are designing your DHCP environment and where you put your servers is what happens if a server fails. Now, in the old days, before Server 2012 and especially R2, was you basically would use a lot of things like split scope. Remember that? You would do one of your scopes on one and then on another, so that way if any client requests come over, you would do that. Or you would do failover clustering, right? You would do that as well. And of course, some people said that that's a legitimate way of doing it, and you can still do this, by the way. It's not like that went away. But when we hit Server 2012, Microsoft introduced DHCP failover, which is kind of cool. What this allows you to do is you have two DHCP servers can provide IP4 addresses and configurations, things like your gateway, your DNS servers, and all that stuff, for, look at this, shared scopes. And the way they do that is by doing redundancy. So for example, and I'll actually demo this, we've got DC01 and then you've got SC01 in my Nugget Lab, right? And so over here, I've got a 172.16.0.0 scope, and then I might do also the 172.16.0.0 scope, and with the appropriate, we'll just say /24/24, and we'll go ahead and create these scopes. And so what happens is that the DHCP clients renew their leases, right, all the time. But if it fails, the leases time out, the clients no longer have IP addresses. And so what you do is now you can configure them to replicate the lease information. So basically what DC01 is doing is that it replicates this information over here, so that way SC01 has it. And the cool thing about it is, check this out, does not require failover clustering. You don't need it. Okay, but what you are going to do is you're going to create what they call a failover relationship. So we'll call it the FO, failover relationship. And in that relationship, basically, you're going to create a partnership between the two servers. And by the way, you can have multiple failover relationships with as many DHCP servers as you want, but they will each have a unique name. Like I might call this the Nugget Lab failover, because I only have the two, so that kind of works. And so you literally are going to create this. Now, there are two types of modes, as we're going to see: hot standby and load balancing. Hot standby, basically, we would say that DC01 is the primary server. So you're the primary, okay? So it's the domain controller, it is the primary server, so it is up. And then the other one is, obviously, if that's the primary, this is going to be the secondary, okay? So this is the secondary server, right? And so the secondary DHCP server will only take over the assignment of IP configurations for the scope of the subnet if the primary server goes down. Now that would be bad in my environment because I only have one domain controller, but just kind of ignore that fact, okay? I know people going, how can I ignore the fact? Now I would of course have more than one domain controller in my environment. And so the DHCP server can act as the primary for one scope and then get this, a secondary for another. So if I create maybe a 192.168 scope over here, we'll also do a 24. Guess what? It will then duplicate that information over here, and then this would be the primary, and then this would be the secondary. Now this is kind of cool. So that is the hot standby method. Now the default, though, is not this hot standby. The default is the load sharing. Okay. Now the load sharing is going to be where both servers will supply the IP configuration to the clients. But what they'll do, and by the way, it just depends, there's a ratio. The default, by the way, is a 50-50 ratio. So about half of this scope would then be handled by this one, and half of the scope would be handled by the secondary one. So that's basically the two different ways. Now there's also an option. There are DHCP failover options. There is MCLT, which you can see here. MCLT stands for, by the way, the maximum client, I'll just do maximum client lead time. So that's the one way of doing it. Basically, you determine the amount of time a DHCP server will wait when a partner becomes unavailable, and then we'll assume control of the address range. The value can't be 0, by the way. Can't be 0, and the default is 1 hour. You might want to remember that for the small, well-lit room. Now, auto state switchover interval, on the other hand, is basically whenever a server loses contact with its partner. Now, the server obviously has no idea what causes this relationship to fail, and so what it does is it will literally say you have a communication interrupted state. And so basically that'll happen until you as the admin manually change the state to the partner down state. But you can also enable automatic transition to the partner down state by configuring the auto state switchover interval, and that would be, the default by the way is 10 minutes. Now the cool thing is that that's not too bad, because a lot of people go, 10 minutes, that's horrible. Well, remember, the default on your leases on your IP addresses is what? 8 days is the default on your actual, what do you call it, on your lease. And so that means that within 10 minutes, if it just so happens, yeah, you might have people kind of calling going, hey, I'm not getting an IP address. Well, that'll trigger you going to check it. And then by the time you get on there, it's already fixed itself. They're probably calling you back going, oh, never mind, it's working. Now there is, of course, message authentication, because Windows Server 2012 enables you to authenticate failover message traffic between the replication partners, and what you do is that means that you are going to use a shared secret. And that shared secret is going to be a kind of like a password, okay? And that validates that the failover message actually came from the failover partner. It's not somebody trying to sneak in there and going, yes, I need to give those IP addresses on. Now, of course, that's one way of securely doing it. By the way, some firewall considerations to think about, something to remember for the small Waylet room, and that is this is TCP port 647 is what they listen to for failover traffic. Okay, so you'll need inbound and outbound firewall rules, and the cool thing is that DHCP automatically does that for you on TCP port 647. But let's demo exactly how we would set this up in our environment. So here I am over here on DC01 here, so scroll it over here, you can see what we've got here. So DC01, I went ahead and added my other DHCP server, which, surprise, surprise, is over on my System Center 01. And of course, I just added this into my console, which, by the way, you just simply right-click on here, and you can add, oh, I'm sorry, up here. You right-click on here, and you add server. And then you just do that, okay? Now, to do failover, you come over here to the DHCP for IP version 4. Notice that it is up and authorized. I got my check mark here, which is good. That means it is up, not down, like you see my IP version 6. I've not set up any scopes there. You can see I have one scope in place, which is 172.16, and it is active, just like I was kind of demonstrating. Now, you can also go to the scope itself and do this if you want, but you simply right-click, click on Configure Failover, and up pops the happy wizard, Configure Failover, okay? Now, I only have one scope that is available. You can select all of them if you want, just depending on what you want to do. We'll go ahead and click on Next, and we want to do a partner server. Now, notice if I down-click, I don't have any because I haven't set any up, but when I click on Add Server, I can go ahead and click on Browse, and in this case, we'll go ahead and type in SC01. Go ahead and check the names on that. It says, yep, I know that one. Go ahead and click OK. We click OK, and now it goes on out and says, yes, there is an SC01. Sounds good. We click Next and says, what do you want to call the name? Now remember, this name has to be unique in your environment. So what I'm going to say is this is going to be Nugget Lab 1. Okay, so that's what it's going to be. You can put in the maximum client lead time. Now notice this is 1 hour. We said that's the default. I'm just going to do 10 minutes on this. So we'll do 0, we'll do 10 minutes. Now notice, what is the mode? The mode is load balance. I can change it to hot standby, and it'll say what is the role of the partner server. The partner server will be standby. That's because it's the secondary. And how many addresses are reserved for the standby server? And then you can place that in there. Do you want to do the state switch over? You can do that if you want. What is the interval? We can do that under 60 minutes. And do you want to enable message authentication? In this case, the shared secret is going to be so top secret that you'll never guess, mostly because I didn't tell you what it was. And so, simply, you click on Next. It reminds you that, okay, it's going to be a hot standby, Nugget Lab 1. Maximum client lead time is 10 minutes. The mode Again, hot standby, 60 minutes is the state switchover interval, and the partner server is going to be in standby mode because we're doing hot standby. And then the addresses reserved are going to be 5%. You immediately click on finish. It goes in and it says, dun, da, 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 it is successful, and happy, happy, happy. We now have a failover in place. Now if I come over here to IP version 4, and I go ahead and refresh, look at what happened. There before I didn't have a scope, and now all of a sudden, dum, da, da, dum, I have a scope in place. And so that's how easy it is to configure DHCP failover. So we looked at a couple of things. Number one, the different ways that we're going to add our DHCP servers to the infrastructure, whether we're going to centralize or distribute. We also took a look at how we would set up failover. So that way we have DHCP failover in place, so that way if one server goes down, the other one comes and picks up the slack. I hope this has been informative for you, and I'd like to thank you for joining me.